Okay, so now we're going to move on to transforms. So there are many types of transforms. There's scaling, rotation, reflection, translation, and shearing. And we're going to represent all these types of transforms with matrices, so that when we want to transform an object, we just need to take their xyz coordinates and multiply them with the matrix. So the first matrix we're going to look at is the scale matrix. So if you want to keep all of the ratios in some image or some object the same, you just want to make it smaller or larger, then you would just create a scale matrix right here, and that would just have your scaling factor on the diagonal and then zeros on all of the off diagonal entries. We also have a rotation matrix. In 2D, it would be defined like this, and that would rotate any object or image you want in reference to the origin. So just make sure when you're rotating some object that it is in fact being rotated as you want in reference to the origin. Okay, and then we also have reflection. You can kind of puzzle out how to do this, but as a spoiler, you would just make all of the x coordinates negative and keep the y coordinates the same. Okay, and then on to translation. This one gets a little tricky if we are trying to display it as we have the past couple of transformations, since we can't actually express this in a 2x2 matrix. So we need to switch to the homogeneous coordinates. This is a normal xy coordinate, a normal xyz coordinate, and then we add a extra value on the end in order to be able to express these translation matrices. So if it's a point, then we would have a 1 at the end of our coordinate, and if it's a vector, then we would have a 0 at the end of our coordinate. And this is so that operations on these points or vectors, so addition or subtraction or what have you, all still make sense within this coordinate system. So what does this do? This allows you to express your translation as a matrix. So as you can see at the bottom here, we added this extra 0, 0, 1 row at the bottom of our matrix, and now when we kind of compute out this matrix multiply, it'll give us translated x and y coordinates. Okay, and then just a note about composite transforms. We can perform multiple transforms at the same time, but you just have to be careful that you know which order your matrices are being applied. So normally we apply the coordinates to the rightmost matrice first and then go right to left. So if you want to rotate first, your matrix needs to be on the farthest right, and then if you're translating after that, then it would be next to it. And then you can multiply these together in any way you want. So you could multiply all the matrices together before multiplying your coordinate by any of these matrices. Just make sure that they're in the right order. Okay, so now we're just going to move on to the questions on the worksheet.